In today's videos, we're going to solve trig equations. And hopefully, you'll find that it's really not that tricky when you think about all the equations we've solved throughout the year, because the process is just about the same. Anytime we want to solve a new type of equation, we first get it by itself. Then we figure out how to undo the operation. We use an inverse. And then we finish solving whatever was left inside. So that's kind of the process here. Isolate, and then undo, and then finish solving. So let's see how that looks for these examples. Cosine squared of theta minus 1 equals 0. We want to figure out what angle theta has to be, and I'm going to limit it and say that theta is only in numbers between 0 and 360 degrees. So first, we will isolate the trig ratio. Usually, that's not that hard. Usually, there's not that much going on here. We'll add 1 to both sides. So cosine squared of theta equals 1. And keep in mind that that's not isolated, because the cosine of theta isn't by itself right now. It's still being squared. So we do still need to get rid of that square with the square root, the same way we've done it all year. Now, be careful. When we take the square root of both sides, we do have to remember that the square root of the cosine squared of theta is actually the absolute value of cosine of theta. So it's really the absolute value of cosine theta equals 1, which means cosine theta either equals 1 or negative 1. So remember to put that plus or minus there, and what that means for us is we actually now have two possibilities. The cosine of theta could equal 1, or the cosine of theta could equal negative 1. And every time we split into multiple possibilities, what we're going to do is kind of write them out separately like that. Okay, we've isolated the trig ratio. Now we need to undo the trig ratio. And there are two ways of thinking about this. The first way I'll show you is actually not the way you're probably going to think about it. It's the more formal way. But the idea is, just like when we have the squared, we take the square root, or we have an exponential, we take a log, or any other time we have a function, we undo it with its inverse. We'll do the same thing here. We will undo the cosine by taking the arc cosine. So arc cosine of the cosine of theta equals the arc cosine of 1. Give myself a little bit more. Equals the arc cosine of 1. Now the whole point of doing this, though, is, and this is why you're not really going to write this out every time, the whole point of doing this is just because the arc cosine of the cosine is the angle. The whole point of inverses is they undo each other. And so what is the arc cosine of 1? It is the angle whose cosine is 1. Well, that actually happens twice, both 0 and pi. Sorry, we're talking in degrees here, so I'll go with 0 and 180 degrees. Both 0 and 180 degrees have a, oh no, actually that's not true, just 0. 0 has a cosine of 1, and so the angle whose cosine is 1 is 0 degrees. Ordinarily, you're kind of going to skip over this step. You don't really need to write it out. You need to have that thought process where you say to yourself, all right, what angle has a cosine of 1? And then you know what the angle is. All right, we'll do the same thing on the other side. What angle has a cosine of negative 1? This one is 180 degrees. And those are the only two numbers between 0 and 360 degrees. Notice how I don't include 360 degrees. Otherwise, I would have to write that as a solution too. And so my solution is 0 degrees or 180 degrees. And that's your answer. Okay, we'll try this on the next example. Sine of 2 theta equals 1/2. This time the trig ratio is already isolated, right? The sine is by itself. So now we're just going to undo the trig ratio. Sine of 2 theta equals 1/2. So we need to say to ourselves, all right, what angle has a sine of 1/2? Well, it's positive, which means, and it's sine, so it always helps to kind of rethink this. Which means it has to be in the first or second quadrant. And we know the reference angle that has a sine of 1/2 is pi over 6, or 30 degrees. So in the first and second quadrant, that means our angle, which in this case is 2 theta, could equal 30 degrees, or our angle could equal 150 degrees. And again, I didn't really write this, but what I just did was I took the arc sine of both sides. The arc sine of the sine of 2 theta is equal to the arc sine of 1/2. The only problem with this is if you type into the calculator arc sine of 1/2, you will only get 30 degrees. You will not get that 150 degrees. It is up to you to know which quadrant to repeat that reference angle of 30 degrees with. And so in this case, it would be the second quadrant. And that's why we have to include the 150 degrees also. Notice how we're still not done. We still need to solve. Our job is not to find out what 2 theta is. But when we said what angle has a sine of 1/2, and that's 30 degrees, well, remember the angle that we're talking about is 2 times theta, which means we still need to solve for theta, but that's easy. Just divide both sides by 2. We'll do that over here also. And then our 2 solutions are 15 degrees and 75 degrees. Number 5, this next one that's down here, is a little bit different. I want to point out something not to do, which usually is not a great idea to show you what not to do, but it is a tempting thing, so I want to make sure you don't do it. It is very tempting to say, oh, both sides have a cosine on it, so let me just divide both sides by cosine theta, and then they'll all cancel out, and that's great. The problem is you are never allowed to divide both sides by any variable expression. Just like if you have x squared equals x. You can't just divide both sides by x and say that x has to equal 1. Because x doesn't have to equal 1. X could also equal 0. The way we would get that is by doing what we're supposed to do, which is empty out one side, so that way we could factor and then split and solve. And you can see when we do it this way, we end up with 2 solutions, x equals 1 or 0. The idea is that if you divide both sides by a variable expression, you might be eliminating a possible solution, and that's why you're never allowed to do it. Well, instead, we are going to do the exact same thing here that I did with those x's, subtract, so we can empty out one side, because factoring only helps when we have that equals 0 here. So we're going to factor, split, and solve. There's a GCF I can pull out, 2 times the cosine of theta, and that leaves me with the sine of theta minus 1. Remember that minus 1. It's very easy to forget about this second term. It's still there. Write that over again. And then the reason to do that is so that we can split and solve. 2 times the cosine of theta equals 0, or sine of theta minus 1 equals 0. And then once we've split and solved, we'll solve them each separately. What angle has a cosine of 0? Well, that happens twice. Theta could be pi over 2 or 3 pi over 2. And what angle has a sine of 1? Well, that is only pi over 2. And notice how our 2 solutions actually overlap with each other. Pi over 2 is a solution twice. We don't write it twice. It can only be a solution once. That ends up being our 2 solutions at pi over 2 and 3 pi over 2. It's worth showing you that if we were to look at a graph of these 2 functions, they would hit each other at pi over 2 and 3 pi over 2. That's where those intersections are. In our next video, we will take a look at problems like this, where instead of finding solutions just within the first period, we're going to find a way to write all of our solutions, no matter whether they're in the first period or not.